Very good afternoon to one and all. I'm happy and I'm privileged to be part of your institution in giving a lecture in this webinar uh, one-day program conducted by the Met University. And I thank all the persons who have stand behind this in organizing this in this great days of a pandemic. And I thank the organizers for giving me an opportunity and also for highlighting the people to be actively a participant in, even though they are busy with their daily routine schedule, they are able to attend this program, which will be a great beneficial for them. And I thank the person who has introduced myself with a good note of mine. Thank you. So the title of my today's presentation is Coastal Structures and Corrosion Protection. So what are coastal structures? So as you can see, the coastal structures can be anything which can be called as a man-made in the coastal area, and they are constructed principally to protect the coastal lines. And what do the coastal structures do? They protect the infrastructure from flooding due to the high water levels of erosions and from the impact of waves and currents. They protect the people who are traveling inside the oceans for their daily routine livelihood and reducing the waves and wave impact. They stabilize the navigation channels by reducing the sedimentations and the inlet migrations. They reduce the erosion by stabilizing the shorelines, beaches, and enhance the recreation, and the beauty of the coastal lines. So why? What is need for us to protect the coastal regions and the coastal structures? So you can see a small example in which there is a mountain or there is a small cliff adjoining to the ocean bed. And these, as you can see, this dark black color rocks is of sedimentary rocks. And these sedimentary rocks are in a position that whenever they are in the coastal regions, these rocks maybe would have formed millions of years ago because of the volcanic eruptions. And after that, in due course of time, they would have changed into this sedimentary rocks. And because of the high wave, tidal waves, and these are highly corrosive in nature, the water in the ocean regions. And this cliff, as you can see here in this region, these waves penetrate inside this rock member. And in this cliff, there is a small crack which is formed underneath because of the water. They wanted to have their own natural way of movement. So what happens at a certain period of time, it may take years for this to happen from the cliff when which the crack is formed. And as the crack is formed, this water from the oceans, they peep inside and they erode this region. They form a small crack, which makes this left side and the right side, this entire rock strata to be unstable. So in due course of time, this crack extends apart, and this is not an artificial way of doing in a painting or so. It's a natural process that crack paves in. These sorts of members you can see in the coastal regions of Bangkok, by which you can traverse inside the cave portions because of the natural wave tides which forms the caved part. So the crack now turns up into an arc-like formation, and there is a separation between these two regions of rock, and they set apart or they pave apart. And after a certain period of time, it falls down from the main origin. This coastal retreat is formed from the reef. The coastal retreat is formed. So you don't have a trace of how this rock was there. So there is no trace. There was an existence of a cliff, and the cliff was disappeared in this position. So to escape from such kind of erosion by wave action, coastal structures are needed. Indeed. So you can see more than 70% of all the coastal structures are on the shorelines for protection from probable damage by storm surge or coastal erosion, which is called as the shoreline protections. So what is the need for us to protect the coastal structures? So the basis of purpose, there are different types of coastal structures which is created. Number one, you have the revetments type, bulkheads, sea walls, breakwaters, groins and jetties, and you have the coastal bridges, piers, dikes, and levees. So here talking about the revetments as the first one. So the revetments of the shoreline structures constructed parallel to the shoreline. You can see these revetments are, this is the shoreline which is constructed in the across the parallel to the regions of your shore. So they are structures placed on the banks of cliffs in such a way as to absorb the energy of the incoming water or the explosives caused by the water and the wave currents. You can see here the wave energy is unique in nature. So you have the solar energy, thermal energy, wind energy. The waves have their own way of energy. They have huge quantity of energy which is saved. So it depends on how much pressure and how much thrust it comes up. So here, this waves and the wave currents, they have the tendency to penetrate inside the coastal region. So in order to avoid the damage along the shorelines, these revetments are created. They are an artificial form of connecting between the bank and the coastal regions. You can use the natural stones or the stones which is available in the natural strata. So a cheaper alternative to seawall is the revetment, which is usually built for the shore protection. So you can see you have lots of recreation clubs or the resorts along the beach lines in many of the countries, including our country and even in our shorelines also. You have lots of recreation places where which along the shores this is placed. So you have to protect the land and also you have to protect the people who are living adjacent to the shoreline from the tidal wave. So you can see the distance between the sea coast and the land region. So this is an artificially created bank in order to make sure that the water level doesn't peep inside and affect the land regions. So the modern revetments have a concrete or shaped blocks of riprap stones laid on top of a layer of fine material. They are fine materials. Here you can see the example of a wrap arrangements by which it has the advantage of good permeability plus it looks really in a natural sense. So here you have the revetments in which it is placed in two different ways. One is the revetments is placed in such a way that you have a geotextile filter underneath this inclined manner. You can see normally we place this inclination of this revetment as 45 degrees. In this sort of arrangements is not only applicable for the coastal bank regions, this is also applicable for even dams and also on the river banks. We place these sort of examples in the river banks also. So here you can see the revetment is placed by using the geotextile filter. You have the asphalts and the sandbags which is laid above the geotextile filters. Secondly, you have the rubble mound type of arrangements in which you have the interlocking blocks and you have the breaking wave currents. So here you can see the armor blocks. This is one type of arrangements of the revetments. This is another type of arrangements of the revetments, by which you have the armor block which is placed here and the rubble core. It's a natural strata. So the natural strata is as such is placed in such a way that the armor blocks are in a position to reduce the energy of the wave currents by breaking the system using the interlocking blocks. So this is the two different types of revetments normally which is applicable in order to protect the coastal regions from the oceanic wave currents. So as I explained in the previous slide, you can see the armor layer, filter layer, and the toe protection mechanism. So here, armor layer is a high wave energy environments, and the riprap stone is a low wave energy environments. The filter layer is the geotextile fabrics to act as a filter under the layer which supports the armor layer, which I've shown in the previous slide. So here it protects the armor layer, which is placed beneath the geotextile. The door protection prevents undercutting and provides supports for all the layer materials. Coming to the bulkheads. So revetments and bulkheads are the typically formed coastal structures in any part of the world. So you can see different sorts of bulkheads universally which is used. In the olden style of creating the bulkheads by using the timber members. So nowadays we don't use the timber bulkheads because their durability is quite lesser. So in order to make sure they stand alive for 20 to 30 or 40 years, we don't recommend the timber bulkheads. So these bulkheads are vertical retaining walls to hold and prevent the soil from sliding the sea inwards. So this is the backwater you can see. During a heavy tidal period of time, these backwaters will have their layer of water rising as the tidal waves peep inside. As you have the backwaters along your ECR from Chennai to Mahabalipuram, if you can traverse, there are lots of backwaters available. So we have the revetments and the bulkheads along the backwaters in order to protect from the backwater tidal waves. So here the bulkheads reduce the land erosion. Here we provide bulkheads not only in the coastal regions, we also provide along the harbor. You can see a harbor here adjacent to this region in which the soil is getting eroded because of the height during the high tidal wave. So here this is the concrete bulkheads. You can see these protrusions, these concrete protrusions, these rectangular components will have the capacity to reduce the energy of the water. They slow down the energy of the water so that the soil adjacent to this layer is not permitted to corrosion. So here this is an example in which a house is constructed adjacent to this water regions in which the bulkheads is created in order to protect this land reserve from damage against the wave action. Coming to the sea walls. So this is another sort of coastal structures in which it is formed of hard and strong coastal defense constructed on the inland part of the coast to reduce the effect of the strong waves. They separate the land from the water. So you can see here the sea wall, and the sea wall is in a staircase manner. It's in a stepped manner. As many of you would have been aware of, why do we create step-like arrangements along the coastal regions? So when you create the step-like arrangements, the high tidal waves, when it comes up during cyclone or heavy monsoon regions, or where during full moon days and new moon days, when the tidal waves are very much greater, these step-like arrangements will have a tendency to reduce the energy caused by the waves. So when they traverse from one step to another step, and the tidal wave energy is reduced, and the damage along the coastal regions is also reduced. So this picture shows the granite block seawall, where the locally available granite stones is used to place or to build this seawall, and some part of this seawall is damaged, as you can see, because of the possible erosions, or maybe due to the very poor interlocking arrangements between this rock strata. See, whenever they create this seawall, you can see here in this picture, this is a perfectly vertical seawall, which is exactly vertical to the shoreline or to the sea basin. So when you create a member which is exactly perpendicular to the shorelines, this interlocking between these members should be strong enough so that the undermining works, you know what is an undermining works. So the water will penetrate inside the lower regions of the wall, and they may have a tendency to destabilize the member which is placed in the top region. So this height of the seawall is determined based on the high tidal wave region. So here, this type of sea walls is constructed using the piling up of the block one over the other naturally without any interlocking system. This has collapsed mainly because of there was no interlocking systems between the one stone to another stone. That's why it has failed. In order to remove those disadvantages, if people have now come forward to and they are able to design this sort of curved walls. This curved sea walls are designed to enable the wave to break and to dissipate the wave energy and to ripple the wave back to the sea. But you can see these sorts of curved. The purpose of creating this curvature of 15 degrees and 15 degrees to this curvature should be less than 20 degrees in order to make sure this the curvature of the natural water boundaries is 15 degrees. So they pave our inside and they move outside without causing any damage. This is a concrete the seawall which is curved shape in nature. So this is more advantage rather than piling up the natural stones one over the other. So this is a good example of a seawall which is constructed vertically and it is adjoining to a mountain regions in most of the European countries in the cold parts for which normally the highways runs between along the regions of the mountain regions. So the seawall is constructed parallel along the shore and they have to make ensure that it will last for 20 to 30 years. So coming to the breakwaters, the breakwaters are large scale structures constructed seawards and usually they have shorelines and they attempt to break waters incoming waves before they reach the shorelines or the facility. A good example is we have the breakwater systems in our locally in our beach, the local beach which we have in Chennai is the Marina Beach. So you have lots of breakwaters in the northern regions of Chennai. Also, you have the breakwater systems from our harbor to the Ennur port. From till Ennur port, you have a lot of breakwaters adjoining to the coastal regions of Chennai, by which they protect the coastal regions and also they make sure that the vessels which is coming to be parked inside the harbor, they are capable of traversing easily inside the region. So this is a photograph in which a single breakwater is attached or detached depending on what they are being designed for. A single detached breakwater may protect a single section shorelines. A single attached breakwater may be a long structure to shelter the marines and the harbors from the wave action. So this is a good example of a breakwater, and this is another adjoining their breakwater. This breakwater is created in order to have this bay system. So this bay system is created artificially so that from the outward regions, the small boats or the vessel which is carrying the material which is to be transported from towards this land region, they pave inside, they park, and they unload the system and they move off. So here this is the roadway system which is created here. This is a breakwater and this is another adjoining breakwater just to stop the or reduce the tidal wave systems over here. Headline breakwater. So here you have the traditional breakwater where it's the loss of one of the critical point to be remembered whenever we create some structures against the natural strata is the currents. So here, since it's something which we deal with water, one of the factors to be kept in mind is the eddy currents. So here you can see the prevailing waves, tidal waves is penetrate inside, and this will cause a very dangerous eddies. So large quantity of here you can see large portion of erosion happens over these regions. So optimized breakwaters, when we provide an optimized way of breakwaters, the eddy currents are comparatively lesser to the previous one, and when the moderate erosion is caused. Here, show connected to the smooth breakwaters, so no eddy current is formed and very less. The erosion from the second diagram to the third diagram is comparatively lesser. And here in the fourth slide, you can see the erosion is very much, no eddies are formed. So this sort of improvement can be done only when we have a proper arrangement of how the previous cases we have and what sort of breakwater systems should be designed for to make sure that the wave currents are in a position to maneuver less sort of erosions. So this is an example of a detached breakwater. So the detached breakwaters are constructed away from the shoreline, usually slight distance offshore. They're designed to promote beach depositions on the leeward side. So on the leeward side, it is created. So that is an example. So groins are the oldest and most common shore-connected civilization structure. They help to create or widen the beaches by capturing the sand moving along the shoreline. So coming to the groins. So when we talk about groins, so here you have is an active structure extending from the shore into the sea and most often perpendicular or slightly oblique to the shorelines. So what are the various systems we have? So one of the systems which we have is the type of the various types of groins are the normal or the straight, inclined. This is some of the various different types which is available. So here you can see this I-type groins and the L-type and the T-type, and you have this inclined one and you have the curved one. So these are some of the different forms of groins, which is an artificially man-made one, which tends to lessen the tidal waves energy. And here, because of this created types of groins, no tidal waves the influence because of the tidal waves is kept negligible on the other side of the bank. So what are the different characteristics of groins? And they are usually made of tropical hardwoods and which are mostly resistant to the marine borders or erosion. So they should have a capacity that they are not easily erodible. And few are more concrete. Nowadays, previously, hundreds of years ago, or maybe during 200, 300 years ago, before concrete came into existence, they were using only the naturally available timber materials to protect the shorelines from the tidal waves. We don't have an history of what has happened, like a tsunami has happened 300 years ago. We don't have proper history of what has happened to the coastal regions. So nowadays we use concrete and steel, and in most recent times, large quantity of rocks are used as the groins members, and they are spaced 50 to 100 meters apart, and lifespan is 20 years. So this is the type of groin which is created in a hexagonal manner. You can see in a the groins extending towards a few distances coastal regions. Now coming to jetties and piers. The structure extended to the sea, lake, or river to influence the current of tide and to protect the harbor, a protecting frame of a pier, and it's a wharf. These sorts of mechanisms you can see in most of the resorts in Mauritius and Maldives. So many of the resorts which is created inside the coastal regions, there are very few large numbers of islands, and they all these small islands are converted into mainly for recreations in Maldives and Mauritius, which is the only source of income for those countries. So here, these wharf and jetties and piers are an artificially created maneuvering mechanisms in which they are also used to as a landing for small flights inside the ocean. So you have flights which is landing inside the ocean in the small islands in Maldives and Mauritius. So in Mauritius, flight lands in the sea, and they take up the people from the sea, inside the sea, to the land towards the coastal bank by using these jetties and piers, which are created by using this locally available natural timber materials. So this is another example of how the jetties are created here from the coast to the to certain distance inside the oceanic part. They are short, normal stone structures commonly used for navigation channels and stabilizing inlets. So some of the jetties which is created is not only to protect the coastal regions, they're also these sort of member are created artificially in order to channelize the navigation systems. So easily, as per the water currents, the people can take up the small boats or ships to the inside to traverse inside the sea regions. So what are the different characteristics of the jetties? They prevent intrusions of longshore sediment transports. They cause higher flow velocities, explore the channels to the deep requirement for the safe navigation. So you can see here, this large part of this jetties is created in order to separate from the main bank. And the wave currents are in such a way that when they hit this conical part, it is reduced considerably, and not much amount of water waves outside the backwaters. So this is a good example of the coastal bridges appears in some of the countries. So here, this bridge is created in order to have a transportation mechanism from one mountain region to another mountain region, by which it is separated by this sea line. So here there is a bridge which is created, which serves as a connectivity between this island to that island. This is another example. This is the highest bridge in Cuba, which is separating between the two mountain regions, and underneath these mountain regions, the backwaters moving off from the coastal region. Dikes and leaves. So these dikes are typical earth-like structures, and they keep elevated water levels from flooding interior lowlands. Sometimes they refer as dams also. So you can see here these dikes, not only in river banks, they can also be constructed along the low tidal regions. So the low tidal regions, these dikes and levees plays a very important role. So this is another good example of the levees which is placed here. You can see the water bank on the adjacent regions of the backwaters. The levees are placed in which the natural strata is created by using the natural strata of the rock regions. It separates from the coastal regions by using a concrete and the steel encased member, which makes sure that the water, the tidal waves doesn't creep inside the other side of the bank. Sometimes we use the member which is called as the gabion. This gabion is an emergency shore protection mechanism. As you can see here, not only in river banks, these sorts of gabions are, you can see a gauge-like structure of 1 meters cross 1 meters. So inside this gauge, the rock pieces are stuffed in. So the stuffed rock members, which is called as the gabions, they are arranged like this. Okay, so in 45 degrees of inclination along the region, they have the good interlocking systems. So this, as per this slope, this gabion mattress is called as the gabion mattress. It is arranged. So what happens is this gabion has a good interlocking systems between each other. So this diagram shows how they are piled up. So you can see they are not exactly placed vertically, one over the other. There is a small interlocking space. So this interlocking space is make sure that this will not fall one over the other. And here there is an inclined manner of 20 degrees. These sorts of gabions, as the natural strata of rock is used inside the caged material, they will not have a tendency to segregate from each other, and they will not fall down. So these sorts of examples can also be seen in the river banks of Himalayas, in the adjacent part of Kulu Manali river bank also. The Ravi, Bias, Satluj rivers, in which during heavy flood regions, previously few months before also there was a huge mishappening because of the avalanche. So the snow on the Himalayan mountains, they collapsed, causing avalanche, and here huge flood occurred on the river banks of Bias River. So because even though the gabions were placed in the adjoining banks, because of avalanche, no one can ensure that what sort of pressure it comes up. This entire member collapsed, killing many of the people along the regions of the rivers. And also people who are working inside the tunneling along the rivers of the bank were also, they caught up inside the avalanche. So nothing could avoid the natural happening, even though you use a system which is highly protected. So they are stacked to form a simple wall and used to protect a cliff of area in the short term, and they have more advantages in a short period of time. These are some of the examples of the concrete armor units which are used to act as a protective region, or to act as a protective member from the ocean currents. So you have the massive, bulky, and the slender components. Previously, we were using shapes like these, and nowadays we use very slender. They should not be lightweight. They should be hardwood strata, which you have the tetrapod, dollars, and these shall even nowadays the most commonly used configuration is this tetrapod. And we use the CB shapes also at some places along the coastal regions of Goa and Mumbai. Sorry. So the X-block and the tripodal blocks are vastly used, and along the coastal structures. You can see they are piled up in the natural rock strata. These rocks are from the locally available region. And these tripodal blocks are artificially concrete blocks, which is piled up like this randomly. They need not be interlocking. They are already a concrete member which they are heavy in shape. So they can be just placed as such. So the tidal waves, the water current, the energy of the water current is reduced considerably. Have this previously you have the tripodal block, and you have the another sort of tripodal block along the see here how they are piled up just to protect the seashore from the harbor. So this harbor is protected from the ocean waves. So what are the importance? They protect the harbors and inlets that are important commercial and military links, and they protect the shore-based infrastructures, the beach and the shoreline stability control. They stabilize the navigation channels, and the coastal communities and roadways and bridges are protected. They are protected from heavy floods and recreational activities. So this erosion by the waves action are to be taken up into an they have to be paved in. So more than 70% of all the coastal structures are on the shorelines for protection and probable damage. So this coastal regions must be given importance always. So when we come to the assessment period, so whenever we see that there is a problem or there is a reason behind why we need to protect our coastal regions from heavy tidal waves or during cyclone, the cyclone that which hit our country along the Bay of Bengal region a few days ago, and 2 weeks before the Arabian Sea, there was a huge cyclone. So both east and the west, we faced a lot of problems in the month of May. In a single month, India was in a very critical position that two extremely worst cyclone was hit. So we have to make sure what sort of, before prevention is better than cure. So we should not think what we have to do on the moment. So we have to be prepared of when I will face a problem. If I face a problem, what sort of assessment patterns I'm supposed to do, what sort of preventive measures I'm supposed to do. So you have to perceive previously of what problems probably you can face. Likewise, so these days we are facing problems because of the COVID, and that would be in the second wave generation we are in. So the entire nation is expecting that what sort of protective measures we have to give if it's a crossing the second and moving towards the third. So the coastal erosion refers to the landward movement of the coastal edge, and the erosion occurs in all the coastal types and consolidated beaches, soft estuarine shorelines, and the harder cliff coastlines also. We have to make sure some sort of protective measures should be ensured to protect the shoreline from the erosions. So the erosion of a cliff coastline is generally one-way process, and the estuarine shorelines are highly dependent on water level, with shoreline positions typically a function of water level with exposure to wave energy as a secondary control. So coming to site inspection, so we have to make sure often we have to inspect the site and make sure that if something bad happens in the coming days, So what sort of protective measures we can provide to the people who are living adjoining to the areas of the sea line? So low sand levels beaches must be ensured. And after 2004, on December 26, when the regions of the few parts of Tamil Nadu was faced a very great devastation because of the tsunami. After that, there was a lot of NGOs which came forward for plantations. That is, vegetation. Vegetation was provided. Vegetation was created along the beach side, so that if something happens in the future, also those the negativity of the natural happening can be avoided. So these sort of vegetation was program was ensured by the government, and it was carried over by many of the NGOs to protect the coastal regions by planting the vegetations. The exposure of beach rocks and the beach face with the which forms as the part of the beach. So here you can see here a few examples in which you have the low beach levels. These are some of the problems which we face. One is the low beach levels, and you can see here the trees are getting toppled up, and this is the structure which is the temporary structure created on the beach is facing a problem. And this is the back shore scrape. And these are some of the problems which they face because of the erosion. See here, you can see the low scale beach mining. So the most of uh, the sandy regions has been has gone because of the erosion. So normally, how do you ensure that the coastal regions are safe in nature? We do have a survey which is called as the aerial survey, where we use the GIS software to make sure the coastal regions are in a safe state. So this GIS mechanism, they are digitalized, and how do you say that the river banks are in a very worst condition of people having their livelihood along the river banks. So only by means of this aerial photograph, we can make sure that the river banks is in a very poor state, or the river banks is in a state of unrest because of people getting occupied during the period of low water levels. So this aerial photographs is a very good measure by which you can preserve the natural coastal line regions. So every period of time, maybe every year, you can compare the mapping system from the previous year, and you can see whether the possible erosion has happened and what is the reason behind those erosions. So this aerial photographs is a very good innovative techniques in which you can protect, you can safeguard our natural coastal regions. So why erosion? The side effects of the erosions are the sediment budgeting. So the sediments which is deposited because of the mechanical biological weathering process, and they within the lagoon. So this biological productions, lagooning is the process in which you can protect the seashore. Like many of the natural vegetations which is also present in the lagoons, like you have the Sundarbans, and you have the even in Tamil Nadu we have lagoons where which a mangrove forest is created. So the mangrove forest is a very good measure in which, because of the mangrove forest only, the tidal waves, the tsunami effect was the effect was very lesser. There was no effect in the coastal regions of Chittambaram in Tamil Nadu when the tsunami waves hit the regions of the Tamil Nadu coastal lines in 2004. So the erosion of the inland areas with material carried out on streams is also avoided. So these are some of the uh, I just don't want to explain more about this because these are naturally occurring thing, and we have to protect the environment so that the hazardous occurrences are avoided because of the many of the natural examples. Maybe it may be due to the erosions, or maybe due to the flooding also, and they may cause due to the moderate erosion also. Major coastal flooding may occur, or because of the tsunami also. So they should not be catastrophic. So The infrastructure completely destroyed multiple downstream infrastructure, which is severely affected. Multiple fatalities may also happen. So these are the ways in which we can protect the natural strata from any dangerous mechanisms. So we can protect the erosions and accretion of the natural process, and they affect the road, maritime status, and the geographical formation. The geographical natural formation should not be dislocated, or they should not be, the mapping system should be the same for a certain period of years. They should not keep on changing. So if they are keeping on changing, then there is a possibility of erosion which is not happened. So avoiding, or how do you manage? There are lots of programs in which there are in non-governmental programs is there, or government-sponsored programs are there, in which you can relocate the hazardous zone. So this hazardous zone is protected from the natural regions. You have lots of benefits, and the risk factor is also ensure that it is kept negligible, or in due course of time it is considerably reduced. These are some of the barriers. Perceived loss of land unavailability for relocation services required and may not be economically viable, legacy issues, and you have the ownership's rights also. So these are some of the programs which is called as the environmentally based approaches, which is called as the EBA approaches. So there are lots of EBA approaches in which this ecosystem is protected to the most possible extent by creation, or by artificially creating a vegetation mechanisms with the shorelines. I'll show you some of the few examples in which these hazards can be reduced considerably. So the most effective way to manage the risk from the hazard is to avoid the hazard altogether. Not considerably, they are reduced in a short period of time. In due course of period only, they can be reduced, so they can be brought under control. There are lots of restrictions also from the existing developments. The restrictions on the developments in a small period of time, and so that the road lines, the power systems, and the waters in place of in place where the social activities are happening can be highly influential. So where you have recreational clubs or people who are coming together in a off late, they are coming together. So that those sorts of uh, places should be kept under control always. So as I told you, the ecologically based approach, EBA approaches, is a very common pattern which you can see in many of the regions. By creating an offshore vegetation such as mangroves, and also they have a position to dissipate the energy, so to dissipate the wave energy before it reaches the shorelines, and traps the fine sediments, and they maintain the habitats of juvenile fishes and marine species. So this natural strata is protected to a very large extent. The backshore vegetation to reduce the wave run-up extent, and they improve the coral reef. So this coral reef, offshore vegetations, mangroves are some sorts of examples which we call as the EVA approaches. So here is an example in which if you can see in a very close manner, here you can feel the tidal waves getting the disturbance in the resorts or the recreation clubs which is placed along the shorelines. They are highly influenced because of this tidal waves. So without the ecologically based approach, EBA, with EBA, you can see here, small vegetations are created artificially. So this tidal waves, when they don't have an influence on the coastal regions. So this natural vegetations protect the shorelines. So these recreation clubs are kept in safe. So this is another example. You can see it hits and this entire mass is collapsed. Here also, because of this vegetation which is created, they are hitting, but the damage in the coastal regions is considerably averted. So they are magnified and shown here. This vegetation absorbs the wave energy, and the destruction is considerably lesser. Here, this one full block is destroyed. So there are different mechanisms by which you protect. some of the structures we call as the rigid structures and semi-rigid structures. So what are the rigid structures? They protect the land from resisting the coastal process. And you can have examples like reinforced can be a concrete member or RC member. It can be coated blocks, timber or steel members. They can be well founded, preferably they in a hard strata. They should not be in a position that undermining should not happen. So that sort of protections you can give. This is an example of the rigid structure. You have the rigid structure here. So here the interlocking is placed between the stone members is created naturally by using the concrete. And here you have the semi-rigid structures. The semi-rigid structures are the one, it's the rock revetments, or it can be concrete armor unit, articulated blocks, and they can be sand filled geotextile bags also. Here you have the semi-rigid examples structures where you have the sandbags, which is piled one over the other at an angle of 45 degrees, or you have the stone-like arrangements which is piled together to protect the shorelines. So here you can see a vast shoreline destroyed because of the tidal waves. This entire unit is collapsed. There was a wall which is created. This is a shoreline wall, and because of the dynamic action of the water current, it has creeped outside. And this wall has broken up. So you have the offshore structure, this aerial photograph in which this artificially created uh, buns-like structures, where which the tidal waves from this side to this side, when they penetrate in the wave energy, the energy because of the tidal waves is reduced and the coastal lines is protected. You can see how many people are living in the adjoint area of the shoreline. So these are some of the failures, examples of failures. Here you have the outflanking, and you have the overtopping. See here you can see this example, the overtopping. This bags, the sandbags has collapsed. One over the other, they have fallen outside. So here it's an undermining. Can you see here? This water peeps inside, and so the erosion has happened in the underneath the sandbags. So these are some of the examples, and we use geotextile bags for the concrete masonry blocks also. This is a very good example, the geotextile bags, which is used not only in the riverbanks or the shoreline structures. Nowadays we use these sorts of mechanisms for the revetments also, and also where which you have the snow loading being higher. Because of the snow load, you have to protect the regions on the highways in European countries. These mechanisms are used. So these are some of the examples of how you can protect using this geotextile layer. This is a geotextile member container. See, they are manufactured like woven, like how we weave the cloths. They are woven, and here the sandbags is placed, and the water level, even though it is rising, it is not under threat. So here you can see the main causes of the failure, different failure mechanisms, as I've shown here. This is the original one, how it is distorted from this layer to this layer, and from undermining, sliding happens, and overturning. So these are some of the failure mechanisms which can be averted. So this is undermining, sliding, and overturning. Sometimes slipping may occur. So here liquefaction, because of this liquefaction, the failure has happened, and here erosion has happened. So here you can see how the liquefaction has happened. It is curved outside. So original wall was like this, and because of the liquefaction, the soil strata underneath this wall has become very loosened. So because of the liquefaction factor, this is creeped outside, and the tidal wave water penetrate underneath, and it has dislocated the entire wall. And this is a common for 10 MPa, 17.5, 20 MPa, and 17.5 rooted concrete. This is the common water cement ratio and post-segregate mix which we provide to construct the walls as per the National Building Code. And I would like to give some of the examples and move forward. see, one of the things which we need to give a much importance is some amount of money is invested to protect the shorelines, but most of the governments are not oriented whether it is maintained properly or they are not in a sort of threat. Something goes wrong. See, a proper maintenance is needed every 6 months. So these coastal banks should be kept under maintenance constantly. Otherwise, if you are not maintaining properly, then the amount which is invested on that goes up waste. So that's called as the environmentally friendly mode of dealing. So I would like to give one few example. With that, I will close. This is an example of, this is an ongoing project of L&T, which I'm sharing it with you. This is the Mumbai Coastal Road South, on the southern region of Bombay. You have a very, the interlinking between the main island and the adjoining part of the land in Mumbai. You have that bridge, which was constructed by L&T also 2-3 years before. So you would have seen in many of the movies that bridge comes up, right? So here this is another coastal road which is ongoing. It's constructed even in this pandemic also it is going on. So here how they lay the ducts. This is the girder bridges are kept and they are transported from the shore by using these trucks. They are transported. This is a temporarily created member in which this crane is replaced in order to carry up the work. So this is the coastal regions of Mumbai, and this coastal lane is connected by using small bridge members, so that you can avoid huge trafficking and you don't need to traverse from west of Mumbai to east Mumbai by taking road lines. This is another, see, from this region to this region, this 10, 15, 20 kilometers region is aborted. Easily you can travel from this island to that island using this member which is constructed in the sea line. So this is the aerial photographic view of the seashore roadway which is constructed using the mechanisms, bridge taking mechanisms. And this is also the wall which is constructed and the adjoining coast. See, first you have to make sure the dredging process is done properly. So the only if the dredging process is done during the, see here this is a low tidal wave and this is a high tidal wave. So it keeps on changing. Morning it will be high and evening it may be low, or morning it will be low and evening it keeps on increasing, yeah, as per the change in the new moon and the full moon. These are some of the examples or the photographic view of how this road mechanisms is happening, how they are constructing this lane, reclamation works which is in progress along the coastal regions of Mumbai. So here in the previous slides, you can see how they are doing this dredging system, piling systems. This is done in the sea, inside the sea it is happening along the coastal regions. So here you can see the tetrapods which is taken up to protect the coastal regions, and the people are working on the offshore structures. So this is the piling up mechanisms, as you see the tetrapods, and above which the soil is piled up. So they create this natural strata so that this water will not. This is a promenade. Promenade is a place, Bandra, East Bandra of Mumbai. And one of the projects which I just wanted to highlight in a short note, Lakshadweep is an island in which many people are, it's a part of, it's a union territory, as you all know. So it belongs to Kerala government. In the Lakshadweep, the problem that which people are facing these days are, I'm not talking something related to politics, the drinking water is a major problem in their region. Okay, so the problem because of uh, uh, the drinking water problem can be averted, or the new unit which is called as the desalination tank is uh, the proposal was introduced, and this proposal has come to pass by using the low temperature and thermal desalination plant in Lakshadweep. So here it is a desalination plant which is constructed on the sea line. So the salt water which is pumped in, and this is the unit. This entire unit is the desalination unit. I'll show you in the coming slides, where which you can see the LTD plant, the sea water which is converted into a potable water. So the Lakshadweep, as you all know, is the formation of small islands. You have huge lots of islands, and these are the 6 important islands by which many people are living in those regions. And many other few islands are there by which the people living over those regions is considerably lesser. So from one island to the main island, the water, the desalination unit which is running up the water is the drinking water, the potable water is transported. Thank you one and all for being very patient in listening to my presentation. Hope you all enjoyed my presentation. I thank the coordinators for giving me an opportunity for this. Thank you.
Really, it's a very great experience in listening to your lecture, ma'am, actually. It was a
Thank you.
complete exertion around this coastal structures, erosion structures, and also you have not leaved the assessment in the environmental policies and how to maintain it and everything. And also you have inputted the input of this the projects that has been going on currently, so that are all very impressive, ma'am. Actually, thank you very much for that. And your presentation is very crystal clear with nice photographs and everything. It's been very clear, ma'am. Thank you so
Thank you.
much for your presentation. And
Thank you.
yes, ma'am, I have some a few questions to ask about this presentation by the participants.
Yes.
Can I, ma'am?
Yes,
Yes.
yes.
Yes, ma'am. They were been asking what is this liquefaction, and what are all the methods to control it?
Yeah, fine. Yeah, as you all know, when the liquefaction happens, so if the soil strata is very poor in conditions, the liquefaction can not only happen in the coastal regions, they can also happen on uh, the place where which your soil strata is very weak. Suppose if we wanted to construct a building in a very clay regions, when you do the piling system, so we use only the piling systems for creation of the foundations. So if you're using your normal foundation techniques, then because the poor natural soil strata, the water the water table keeps on rising. So the settlement of the foundation happens. Similarly, along the coastal regions and along the river banks also, you don't have a good soil strata along the river banks or along the coastal regions. So because of the poor soil strata, even though you invest a lot of money in constructing the walls using the natural rock strata, piling up the rocks, or the concrete blocks which is interlocked one over the other, the undersoil is in a state of unrest. So when the water peeps inside the member, the top layer of the artificially created wall will topple. So that is called as the liquefaction because of the very poor soil strata along the region. That can be
Thank you.
controlled only if you have a deep foundation in the revetments or the bulkheads or the sea walls.
Thank you so much, ma'am. The next question asked is, what are all the innovative materials that has been came now to resist this wave current in protecting this erosion creating that's erosion control structures?
In order to control the erosion, say erosion happens naturally. You can't, I cannot stop the storm. I cannot stop the cyclone. It's all happening naturally. I can't stop an earthquake. And to be very frank, you can't even predict what will happen. Uh, even when the news comes up that the coastal regions is going to be hit another 48 hours or 72 hours, they will predict that it's going to hit the coastal A. But normally it doesn't happen. It may hit the coast B. So it keeps on changing its path. So you can't traverse the path of the natural uh, thing. So here, how do you protect the coastal from erosion? One mechanism is the new technique which is available is the geotextiles. Geotextiles combined with the sandbags, and you have the as I've shown you the curved concrete pavements, the curved concrete sea walls. The Mumbai coast was hit by the cyclone 2 3 weeks before, but nothing has happened except that the some of the members which was kept for trafficking rerouted from it, but nothing over uh, uh, the roads or the walls which was created in the adjoining region of Mumbai. No, nothing damage, no damage has happened, even though the entire most of the Mumbai coast is along this coastal region. So those sort of mechanisms is an artificially created mechanisms in which you can protect the coast from the erosion. So Mumbai coast is a very good example, even though it was hit by the worst cyclone in the past 10 years.
Thank you so much, ma'am. The next question is, can we stop the coastal erosion fully by structures?
Yeah, of course, naturally. Uh, this erosion can be stopped only by using the artificially constructed structures. And erosion, if it's happening as I shown in the first few slides, if there's a small cliff and the mountain region is getting disturbed because of the tidal waves and they are getting eroded means, and some parts of Phuket and Thailand, the income is only because of this caved mountain regions. As you people would have seen the James Bond Island in Thailand, in Phuket, it is caused because of this erosion only, but they are generating revenue because of the erosion which was created naturally. The revenue because of a devastation. It's all up to the nature. You can't question nature. Thank you.